So we're going to be talking about evaluating functions. Now, before we dive into actually doing some problems, let's go over very quickly, what does it mean to evaluate a function? Well, when we're evaluating a function at a point and we have an equation or some other like algebraic notation, we're going to plug in the given input, so whatever's in that parentheses there, and then we will just simplify to find our output. So we plug in our given input, we simplify until we get our output. Now, I do want to point out that the output could be a number or an expression. It's not really going to matter if it's one thing or the other, okay? It's going to be either of those. So let's look at an actual example where we are plugging in our input, then simplifying to get an output. Evaluate f of 3 for f of x equals blank, this expression right here. So what this is telling me is that this 3 is going to be my input. Okay, this is my input. So what I'm going to do is I'm going to take that 3 that's in those parentheses and plug it in for any x's into my function here. So I've got a negative 3 squared minus 4 times 3 minus 8. Okay, we've done the first part. We've plugged it in. Now we got to simplify so that we can get an output. This is where, a little bit of number sense is going to help us to make sure that we get the right values. So let's start here. We've got 3 to the second power, so 3 squared. That is 9. It is going to be negative. That negative is not included in our parentheses. So we've got a negative 9 there. Okay, let's move to the next values. We've got a negative 4 times 3. That's going to become a negative 12. And nothing happened to our 8, so it just gets to stay at the very end. So now that we've, simplified a little bit, let's simplify even more. So we've got a negative 9 minus 12 minus 8. Well, if I combine all of those, I end up with a negative 29, which is my desired output. I have nothing else to simplify, so I've reached the end. So f of 3 equals a negative 29. That's great, but what about when we have an expression? Like on this next example, evaluate f of x plus 1 for f of x equals 2x squared minus 5. Same idea. Here's our input. I'm going to make sure that I use the same colors. Okay, this is our input. And I am going to plug that in for any x's in my actual function. So I've got f of x plus 1 equals 2 times x plus 1 squared minus 5. Okay, this one's a little bit trickier, but help me out. If I were to remove the 2 and the negative 5, we get x plus 1 squared. From our factoring, we know that if we have a binomial like this, raised to the second power, that we have 2 of those. So this is the same thing as 2 times x plus 1 times x plus 1 minus 5. Hey, we've seen stuff like this before. Let's multiply this out. We're going to ignore that 2 and that negative 5 at the end for just a minute here. Let's just focus on these two values right here. Okay, we've got x times x. We got x times 1. Okay, now let's do this one right here multiplied to both of those values. So plus x plus 1. Can I combine any of those? Yeah, I've got these two like terms right here, so I can combine them. So I end up with the x squared plus 2x plus 1. I didn't forget about that 2 and that negative 5. I got to make sure that those are with it as well. Now before I worry about this negative 5, let's worry about our 2. Let's tackle it from all the multiplication, okay? Following that order of operations. So we're going to take that 2, we're going to multiply it through here. Okay, so 2 times x squared gives me 2x squared. 2 times 2x, that gives me a 4x. And then 2 times 2, which is a plus 2. But I still have that negative 5. I'm almost there. These two values, I think we can simplify those even further. So when I do that, I end up with 2x squared plus 4x, and then 2 minus a negative 5. I shouldn't say that. 2 minus 5, there we go. That gives me a negative 3. My goal here isn't to factor, my goal is just to simplify. We have simplified as much as we can. We stop.